Welcome back to Math 171 Pre-Calculus Algebra. In this video, we're going to take a look at the composition of functions. So, first thing we're going to do here is we're going to talk about two functions, and I'm going to talk about the function c of x is equal to 5/9 x minus 32. You might recognize that formula, although you usually see it in a different way. That is the formula that converts a Fahrenheit temperature to Celsius. But then you may have learned in a science class about the function k of x, which would be x plus 273.15. So that's going to convert a temperature that's in Celsius to Kelvin. Well, now we want to convert a temperature in Fahrenheit to Kelvin. That's something an atmospheric scientist might be interested in, because so often we see weather reports in Fahrenheit, but a lot of the meteorological formulas require a temperature in Kelvin. So, if we're given the temperature in Celsius, or Fahrenheit, we need to get it into Celsius before we can apply the formula. So we're going to take c of x and then apply the k function to that. So all I need to do is take that definition of c of x and plug it into for x on k. So we have 5/9 x minus 32 plus 273.15. And usually we're going to just write this so that it's easier to work with. So I'll go ahead and distribute the 5/9 here, and I'm going to take the liberty. Go ahead and go with 5/9 x, but I'm going to calculate 5/9 times 32. And rounding to 2 decimal places, I get 17.78 plus 273.15. And now I can add the minus 17.78 and plus 273.15. Oops. And I get 5/9 x minus 255.37. Or I'm sorry, plus 255.37. So that's how we do the composition of functions. But there is the thing that in general we have to worry about. So first, some notation. I went ahead and wrote it this way, but this is commonly written as, and I'll use more common notation here. F composed with G. We use an open circle to indicate composition of x, and what that means is f of g of x. So we do have the issue that we need to deal with the domain of this function. So there's two things that we have to satisfy here. 1, x has to be in the domain of g of x. And from this point on, when I'm talking about the domain of a function, I'm going to use this notation of capital D and then put the function in parentheses. So x has to be in the domain of g. And then second thing we have to deal with is that g of x has to be in the domain of f of x. So for example, if f of x is equal to 1 over x minus 1, and g of x is equal to 1 over x. So first things first, from the first rule, we can eliminate x being 0. Because if we have that, then we have a problem. But now we know that 1 over x minus 1 cannot equal 0. So the first thing I'm going to do with this is go ahead and multiply both sides by x. So we end up getting 1 minus x is equal to 0. Remember, when I multiply a side by x, I have to multiply everything on that side by x. I'm sorry, that does not equal 0. Rather than subtract 1 from both sides and then divide by -1, I'm going to take the liberty of adding x to both sides. And I get 1 does not equal x. So we get the domain of this function, we have -infinity to 0, union 0 to 1, union 1 to infinity. So that's composition of functions and how to find their domain. In the next video, we're going to talk about the idea of undoing a function.